An AI agent sounds complicated until you draw the loop. A goal goes in, the model reads the goal. It chooses a tool, the tool runs outside the model. The result comes back as evidence. Then the model chooses again. That is the whole mechanism. Goal, model, tool, observation, stop. Every framework wraps this loop. Some add memory, some add routing, some add logs, retries, planning, or multiple agents. Those parts can matter, but the core is still this cycle. The important part is not that the model wrote text. The important part is that the model received evidence from the world and changed its next move. That feedback is what turns a chatbot into an agent. Frameworks make agents look bigger than they are. They give the loop names. They package prompts. They store messages. They call APIs. They draw traces. They retry failed steps. They route work between roles. Those are useful engineering pieces. They are not the core idea. The core idea is smaller. A model sees a state. It chooses an action. A tool performs that action. The result is added back to the state. The loop repeats until something says stop. That is why two frameworks that look different can behave the same way. They both wrap the same decision cycle. If you understand the loop, the product names get less mysterious. You can inspect what the agent is allowed to see. You can inspect what it is allowed to do. You can inspect when it stops. That is where the real design lives. A language model does not automatically see your system. It does not know what files are on disk. It does not know whether a test passed. It does not know what the API returned 5 seconds ago. It only knows the context you give it. A tool is a controlled opening into the world. The tool might read a file. It might run a command. It might call a database. It might query an API. The action matters, but the observation matters more. The observation is what changes the next choice. If the model guesses the failing test, that is weak. If the tool runs the test and returns the failure, the next move can be grounded. The loop exists because one prediction is rarely enough. A useful agent keeps asking the world what happened. Then it updates the next step from that evidence. This is not production code. It is the shape of the idea. The message history starts with the goal. The loop asks the model what to do next. If the model is done, the stop check returns the answer. If not, the model selects a tool and an input. This line is the boundary. The selected tool runs. The result is not hidden. It goes back into message history. Now the next model call sees what happened. That is the agent loop in code. There are two lessons here. First, the model is not doing the outside work by itself. The tool does the outside work. Second, the loop must be bounded. A step limit is a simple stop rule. A better agent may stop when tests pass, when a verifier agrees, or when confidence reaches a threshold. but there must be a stop rule. Endless motion is not intelligence. It is just an unbounded loop. An agent has 4 moving parts. The first is the model. The model chooses the next action from the state it can see. If the state is wrong, the choice will be wrong. The second is tools. Tools turn a text decision into an outside action. A good tool has a narrow contract. It says what it accepts. It says what it returns. It fails clearly. The third is memory. Memory is not magic. It is the state carried into the next decision. Sometimes that state is a chat history. Sometimes it is a scratch pad. Sometimes it is retrieved notes. Sometimes it is a compressed summary. The fourth is the stop condition. This is easy to ignore. It should not be ignored. The stop condition decides when the loop has enough evidence to quit. These 4 parts answer 4 design questions. What chooses? What acts? What carries state? What stops? Agents usually fail for boring reasons. The first failure is context rot. The loop keeps reading stale, noisy, or incomplete state. The model makes a reasonable choice from bad inputs. The result still looks like motion. The second failure is a bad tool contract. The tool is too broad. The input is vague. The output is hard to interpret. Now the model has to guess what happened. The third failure is no eval. The agent needs a way to know whether work is real. A green check from the model is not enough. For code, run the test. For data, check the invariant. For a claim, inspect the source. The fourth failure is a bad stop rule. The agent stops too early or it never stops at all. Both are design bugs. Most agent reliability work is not about inventing a smarter name. It is about cleaning the loop. Better state, sharper tools, real verification, bounded stopping. Not every task needs an agent. If the path is known, use a workflow. Fetch the input, transform it, validate it, publish it. That path is fixed. It is easier to test. It is cheaper to run. It is easier to debug. Use an agent when the next step depends on what it finds. That is the useful part of the loop. The model reads the latest evidence and chooses the next action. The path is not known ahead of time. This is why agents fit debugging, research, investigation, and messy operations work. The next move depends on the result of the last move. Do not add autonomy where a fixed path works. Autonomy is a cost. Uncertainty is what earns it. The whole thing is one loop. What can it see? What can it do? What should it remember? When must it stop? Those questions matter more than the framework name. A weak agent hides those answers. A strong agent makes them inspectable. You can trace each model choice. You can see the tool input. You can see the tool result. You can see why the loop stopped. That is the difference between a demo and a system. AI agents are not magic. They're loops with tools, evidence, and limits. The framework is not the hard part. The contract around the loop is the hard part.